In this instructional video, we're going to be drawing up the boundaries of this lot in AutoCAD. Hello! Maurieo draws lot boundaries for a site plan. Hello! Welcome. Well, this is a lot from a New Zealand survey plan with showing the boundaries with bearings and distances here. Bearings are in degrees, minutes and seconds, and the distances are in meters. The plan is north is up the page on this plan, as is usual, and we're going to be drawing this up in AutoCAD. So let's go across to the big screen and let's see what we've got. So first of all, here's AutoCAD. So we're just going to open up a new file, new, and I would suggest using, well, the AutoCAD, this one here, ISO, and there it is all set up. Now I've got the thing set up how I like it. I've got the big crosshairs and I've got them coloured red, and here I'm in model space. Now the first thing that I do for this is because I work in meters as a surveyor, but perhaps I'll do this one for an architect, because an architect probably works in millimeters rather than in meters like I do. So the first thing to do is to set it up, units, like so. So set up the units and keep it at decimals. I usually with millimeters we just go to the nearest millimeter, so just 0 precision millimeters. Now up in here I like to work in degrees, minutes and seconds, and the precision is that there to degrees there, and we go clockwise is the way bearings go, clockwise from north, and set the direction to north. And okay, so there we go, and that's that all set up there now. So alright, now drawing the lines and where to start. I started way back in the good old days of before computers and calculators. So when we started drawing or calculating up a lot, we always started at the westernmost point, for reasons that are related to the way we used to do the calculations, but old habits die hard, so that's where I'm going to start. I'm going to start at this point here. Okay, so we're going to draw a line here, and there's the line, and I'm just going to start in there. Now we can see off here, just looking at it, I have to look in quite close, or I might be able to just make it a little bit bigger here. I think I can, and just move that there like so, and we come back in here. We can see that that's 193 degrees 44, that one there. Now 193 degrees 44 is down here somewhere, but we actually want to go up there, but that doesn't matter, because what we can do is we can type in that. So we just go shift chevron, like so for the chevron, and then 193 degrees 44 minutes and 00 seconds. I'll put that in. Okay, and you'll see there the little tab, angle override, and 193.44. So that's good. But depending, I'm going to start and go up. So I want to go. That's the 193, but as I say, 193 is down this way. I'm going to actually go up there. It'll be 180 different, which is 13 degrees 44, and I'm going to go 2306 0 millimeters, and that'll be it there, all drawn up. And Z enter E enter okay, Z enter E enter will give us the extents of that, and there you go there. And as you can see, I've got my properties turned on, and you can see there 13 degrees 44 and 23060. Now don't worry about that it being 13. 13 is going up the page, 13 degrees 44, and if you add 180, 193.44 is going down the page. Alright, so now it's on to the next line, which is here, and well, it's going from that point there, and again, shift with the chevron, and 48 degrees, 48 D for degrees, 01 minutes, 30 seconds, enter, and there's our angle override, and 48:01:30 for 30540 millimeters. Okay, and that's that one put in there like that. Okay, so that's got that all drawn up, and I'm just going to pop over to here a bit and just pull that round a bit, click on that, yep, and then we've got this one here. Okay, so we want to go a little bit bigger, and that's 146 degrees. Okay, so let's this one here, 146 degrees 29, shift chevron, 146 degrees 29 minutes, 146.29, and 18120 for your millimeters. Okay, and then down here 139.51. So again, it's just shift 139 degrees 51 minutes 00, like so. And there's our angle override. Always check for that. Make sure you've got those little tabs showing up there. And that's, now we want to go 39900 for our distance. And there we go. All drawn up. There. Z enter E enter for extents. Oops, what's going on there? Well, that wasn't supposed to happen, so we'll delete that and just push the extents here. Okay, alright, so now we're down to there, and 238, is it 238 or 228? I think that's 228.0550. Okay, so let's have to go back to the line command there. Line. And chevron 228 degrees 05 minutes 50 seconds, enter, and 47090. Okay, and now that's the last, I think that's the last one. I'll just have a flick over to here. Yes, it is. Now 193.52. Now, so now what you do is you just connect back there like that, and you might get a slight difference in here. So we've got 319, 51, 38, which is 22 seconds. So 319, 52. So that's pretty close. These won't what we call close exactly, because it's very difficult to measure out and get a closed figure. In survey terms, this won't close. You'll get a certain amount of error. Errors that might be allowable would be 30 mils north or 30 mils east, either way. So that would be acceptable. When I'm drawing this up as a surveyor, what I do is I do a calculation and I actually adjust the error out and put a little bit at each angle, at each boundary corner, but that's not always possible in AutoCAD, so just put all the error there in that one little spot. But you have to remember that the error is there, because any error that's there, if you then start doing dimensions off this model of the boundaries to buildings and things, you could put the error into the building, and you don't want to do that. So that's why you always leave the positioning of the building open, so that you pinpoint the critical corners, so that it can get the building can be positioned according to your resource consent requirements, and let it float out into the areas where it's not so stringent. If this becomes critical, you need to talk to your surveyor and get an adjusted model made that is adjusting out the error and distributes it evenly. Okay, and for the distance, we've got 4477.4, so we're 4 millimeters out for distance, and in about 22 seconds, whatever the tan of 22 seconds times 45, it's about that. So that's pretty good. So that's it there. That's your closed figure there. And so just if you want to just check the area of it, just use the boundary function there, and just pick a point in the middle, and that'll draw a polyline around it for you. Oh, perhaps not. Try again. View and boundary, enter, and we'll pick a point there. Okay, and that's it there. Okay, now that should yes, there's our polyline, and you can see that the area is 2618.03, which is millimeters. So that's it there. So there you go. That's it. That's your lots there. North is up the page, and what have you. And there it's drawn up in model space. If you want, you could maybe send that polyline clip, send that to the back, maybe, and then you can check the dimensions of each of your points if you just want to make sure. But I think that's pretty good there. So there's your dimensions: 319.52, close enough, and 44744. Okay, so yeah, there you go. That's it, all drawn up in AutoCAD and all ready to go and position your house. But as I say, be very careful dimensioning off this model. Make sure that the house can be positioned without being you're not putting any error from the boundary model into the house. So you might fix one corner and then fix the direction of the other wall so that the house can position itself, and you won't get any error from any of the other corners out to the boundary. Alrighty, So, any questions? Well, make a comment below or get in contact with me. Pretty easy to find on the internet. Just type in maurieo and you'll find me. All good. Cheers. See you.